forged fiberglass, or more accurately, short strand compression molded fiberglass. I've not really heard anyone talk about it, so today I wanted to talk about what it is, what its uses are, and how I got to this point, because it's not quite as simple as forged carbon. Now, the main difference between forged carbon and forged fiberglass is how it's composed. I'm assuming you've watched the Easy Composites video where he talks about forged carbon and how you want about a 60% weight percentage of fiber to 40% resin. I quickly realized with forged fiberglass that that just doesn't work. My first test was this, a motorcycle lever guard, and as you can see, it didn't work. I went for what I thought was a fairly moderate 50% fiber ratio, so 50% fiber, 50% resin by weight. And besides a horrible release, but that was also partially my fault, the 3D printed mold was not up to scratch. The parts suffered from really inconsistent resin. So some parts are really resin rich, some parts are really fiber rich. I mean, you'll be able to see it's horrible. And so after this, I did a bunch of research into how I can make these parts actually work. And I realized that the way you compose forged fiberglass is completely different, or the way you give it strength is completely different. With fiberglass, when the fiber loading gets too high, the fibers like tangle together and it kind of makes them clump together and you get fiber rich spots and resin rich spots. Whereas with carbon fiber, the fibers they spread more evenly around the part. And so let me introduce you to fillers. So fillers are just, So fillers are just powdered minerals, and they allow you to get the desired stiffness or wear resistance or other mechanical properties you want without super high fiber loadings. So in my case, I use this. This is calcium carbonate powder. It's really cheap, it's really commonly available, and it gives me the properties I'm looking for. You can also use things like graphite, talc, aluminium powder. You can use metal powders, and these give other properties like thermal conductivity and heat resistance, all these kind of things. So fillers aren't just a replacement for fibers though. If you had really high filler content and no fiber, you would get a part that's really stiff, that's really dimensionally stable, but it would be really brittle. You know, if you tried to split it, for example, this part here, if I tried to split it, you get just a brittle fracture. So you can kind of think about it like unreinforced concrete. So it's really strong, dimensionally stable, especially in compression. But as soon as you start to try and bend it or stretch it, it will just crumble. The fibers, on the other hand, they also give increased stiffness, but their main job is they provide tensile strength to the part. So if you bend it or you try and pull it, they don't just fracture. So for this part, which is kind of my most successful part, it's just a kind of lid for something. I've settled on a fairly safe composite of 25% fiber, 40% filler, and then the rest resin. So you'll notice that is a 65% solids content, which is actually higher than in carbon fiber, where you typically use around 60%. In future, I kind of want to see how far I can push the fiber content, see if I can get to 30% or higher. The problem is, the higher you go with the fiber content, the harder it is to get a clean, good surface finish, no pinholes, no voids kind of thing. But I think I might have a secret weapon for that, and I'll talk about that in a bit. So why would you use forged fiberglass over forged carbon? Well, the main one is going to be cost. Not just the outright cost, but the strength to cost ratio. For this lid, if I did a price comparison, the forged carbon part would end up at 75 pence per part, and the equivalent forged fiberglass one, which is this one, is about 43 pence. So it's just under double the amount for a forged carbon part for the same one. So if you don't need it to be the outright most strength to weight ratio, you can actually get a better strength to cost ratio with forged fiberglass. Another one is color. Because we're dealing with transparent glass fibers and transparent resin, we can actually use the fillers or dyes in order to get whatever color we want, which you can't really do with carbon unless you want to paint over it. The actual composite itself has to be black or carbon colored. In my case, I've kind of just chosen to use the natural color. So the reason this is kind of like a brown color is because when the calcium carbonate gets wet and wetted out of the resin, it kind of goes a slightly browner color. But you can see the fibers in there. As I say, if I wanted to, I could dye this part, dye the resin beforehand, and then that would give it whatever color I want. And the last benefit, I guess, is that it's kind of more customizable. Because we're kind of forced to use fillers, it means that we can use these fillers to get kind of whatever mechanical properties we're looking for. So for example, if you wanted to create something that was super thermally conductive, you could use an aluminium filler or a steel filler to get a metallic property to that. which would give it better thermal conductivity. Or if we're creating like a mold or something that needs to be really low friction, we can use graphite, and that'll create a really low sliding friction surface. So you can use these fillers to kind of create whatever composite you're looking for. So how did I make this part? Well, first you're going to need a mold. I'm not going to go into a lot of detail on mold design, because if you're familiar with forged carbon, then you'll be familiar with this exact same mold design. But what I will say is that the quality of the mold is really, really important. In this case, this was the mold that created that part, or this is half of the mold. It's kind of held up okay after demolding that part, but it's probably not usable again. With this one, it was 3D printed, and then I used spray filler. So 3D printed, I think I did about 4 layers of spray filler, sanded it back, did another 4 layers, sanded it back again, trying to get rid of all of those layer lines, and then I did a thin coat of epoxy, just to kind of seal all the pores, because the spray filler is pretty porous. And then after the epoxy, I just sanded that back as smooth as I could. I think I went up to 1200 grit, or maybe 1500 grit, and then applied the mold release wax and sent it. I think if I was going to do it again, I'd probably try and look to doing cast molds. So casting the molds out of epoxy from kind of a silicon mold master, because I've seen people get relatively good results in forged carbon with that kind of approach. When it comes to actually molding the part, I found the best way is to mix the resin and hardener first. So I'm mixing that first, then I'm adding the filler. So I'm adding the 40% calcium carbonate. And then I'll mix that as thoroughly as I can together. And then it comes the secret weapon that I mentioned earlier. And that is this. I don't know if you can read that. A tiny bit of fumed silica, or cabasil, it's otherwise known. What this does is this massively increases the viscosity of the part. So it turns the resin and filler, which is relatively low viscosity, it turns that into kind of more of a paste or a putty kind of texture. And then once you've got that, I'm adding in the fibers. As I say before, about 25%. I'm going to try and push that higher if I can using this. And what that does is it means that when the fibers get squashed, they don't stay together as much, because what was happening before is the fibers would stay in one part of the mold, and then as it gets kind of compressed together, the resin would go to the other parts of the mold and the fiber would stay in one place, and that was why I was getting kind of the fiber rich and the resin rich spots. But with this, the viscosity of it helps kind of hold the fiber to the resin, so when the resin moves around, the fiber moves with it, and that should help get way more even consistency all over the part. And then after mixing this for a little bit, I just kind of use this spatula and maybe a gloved hand to put it into the mold and then squash it together. I made a little press to help me consolidate the parts, but you could do this with clamps, or if you've got a vise or something like that, that would work fine. To get the exact fiber ratios and the exact masses of all the parts that you need, I've created this little app. You know, I'll leave a link in the description. It kind of just helps determine the cost of the part, the mass of all the parts that you need in each part. And also I put in a little overfill factor, which you see it's called matrix overfill. I usually leave that around 10%, and that means that it accounts for any kind of resin that's left in the cup or something. So you have more resin than you need, and then when you actually put it in the part, it's going to be about the right amount. But you can expect some resin to squeeze out anyway, it's not a big deal. Once the part's been curing for maybe 24 to 30 hours, I'll try and demold it. With this mold, you can see there's some holes in it, and that was I filled these holes with plasticine and then used some M5 dowel pins to just knock those out. And that gave me a really good demold. I'm not sure if the wax was perfectly applied. I probably could have done with a couple more layers. I think I did 6 or... yeah, probably about 6. And yeah, so just knocking some pins through each of these holes, that demolded the part well. I think I did it about 22 to 24 hours, and the part kind of bent a little bit, so I had to kind of bend it back straight. But then I stuck it for about 6 hours on my 3D print bed. So it was about 40 degrees Celsius for a couple of hours, then I raised it up to about 50, and that just post-cured the part, so it means it just gets its full stiffness and mechanical properties a lot sooner. It also helps with temperature resistance, but I wasn't really doing it for that. I just wanted to cure as fast as possible. So to get to this stage, I had to do a lot of research, because, as I say, forged fiberglass is a lot more finicky than forged carbon, it seems. So if you've got any questions about this, leave them in the comments. I'll try and help you out. And subscribe for more. I'll see you soon.